special angles. I'm going to make a table here and just state the special angles, state the trig functions, and tell you got to have these memorized. Okay? So let's make a little table like this, line going down, line going to the right. We'll put the angle. For now, we're going to use degrees. We won't talk about radians until next week. And then I'll add the radians to this chart as well. We'll start with 30 degrees, 45 degrees, and 60 degrees. These are all special angles because they come up a lot in construction, for instance. And we want to find the sine, cosine, and tangent. So let's go across the top. Sine of whatever theta is, cosine, and then tangent. Kind of separate these guys from each other. Okay. Let me just state what it is and for the sine function, what these values are, and then we'll talk about, well, where do these come from? So the sine function, the sine of 30 degrees turns out to be 1/2. The sine of 45 is root 2 over 2. And the sine of 60 is root 3 over 2. So where does this come from? Let's draw a 30, 60, 90 triangle. And we'll make this the 30-degree angle. So that this length right here, from here to the base of the right angle, is, let's call that A. Remember we called it A the other day? What did it turn out that the hypotenuse was lengthwise? 2 times length A. Anybody remember what the vertical length was, the other leg? A root 3? Yeah. Well, if we think of this guy as, actually, the way I drew it, let's think of the 30 degrees. This would be the 60-degree angle. Let's think of the 30 degrees as our theta in this case, at least for one of these. Then we'll switch to 60 degrees in a second. So remember the SO part of SOHCAHTOA, sine equals opposite over hypotenuse. What is the sine of 30 degrees in this triangle? What's the opposite length in terms of A? Sine of 30, I should say. So what's the opposite of 30 degrees? The length of the side opposite 30 degrees is A. And then SO part of SOHCAHTOA, oh, H, what's the hypotenuse length? 2A. So do you see where the 1/2 comes from? Sine of 30 degrees equals 1/2 because these A's can't, it doesn't matter what the length is, right? A could be any length in the world, and you're going to be left with 1 on top, and you're going to get sine of 30 equals 1/2. So it comes from that 30, 60, 90 triangle. If you do something similar for the sine of 60 degrees, hopefully right away you can see you're going to get the root 3 over 2. To get the rad 2 over 2, you need to draw an isosceles triangle so that you have a couple of 45 degrees angles, and then maybe split it down the middle, use the Pythagorean theorem. You can get the result rad 2 over 2 doing it that way. Okay, so it's not a huge mystery where these values come from, hopefully. It does turn out that the cosine is the reverse of these values. So the cosine of 30 degrees is root 3 over 2. The cosine, so I'm reversing the order here. I'm going from bottom up. Oh, and the middle guy stays the same. The cosine of 45 degrees is rad 2 over 2. The cosine of 60 degrees is 1/2, and you could use this triangle to prove that, the first and the last one at least as well. Special angles, trig functions and special angles. Tangent, it turns out that the tangent, this will be helpful. I'm going to give you a little trig identity ahead of time. And it's easy enough to prove. The tangent of theta turns out to be sine theta over cosine theta. If you put in the ratios, you'll get the right cancellation that you'll get y over x here. This is true. if you go back to the original definition. And so we can use the values we already obtained then to get the special functions of tangent. So, or the tangent of special degree values, if you like. So let me do the middle one for you. The tangent of 45 degrees has to be 1. Do you see why? Because what's the sine, if we change this to 45 degrees, what's the sine of 45 degrees? Root 2 over 2. What's the cosine of 45 degrees? Root 2 over 2. What happens when you divide a number by itself? You get 1. Okay? In a similar way, you could show that the tangent of 30 degrees is root 3 over 3, it turns out. And then the tangent of 60 degrees is just root 3. Okay. So I know that was thrilling, but it was necessary. Not thrilling, but necessary. How's that? Now, you need to know these. And it's best to know them off the top of your head, okay?